Thank you everyone for coming. Today we're going to talk about Gradle and how we can make our life simpler applying the proper techniques. So a little bit about myself. My name is Ihor Herasymenko. I work for a company called Ada. We do customer support automation. These are links for my online presence, although I don't write much there. And I want to start with the non-goals for today. So first and foremost, we will not be talking about Maven versus Gradle. So this is absolutely out of question here. Like, I have my own opinion. I will not try to share it today. I'm not here to sell you Gradle either. I don't work for Gradle. It's just my personal experience, which I want to share with all of you here today. And unfortunately, we will not be able to look at everything that Gradle offers because we only have like 45-ish minutes of the time. So without any further ado, let's jump into the code here. I want to ask all of you, like, who here has used Gradle?
Like ever?
Let's say ever. Who liked the experience? Okay, one person liked the experience. That's great. That's for those who didn't like the experience, hopefully after this talk is over, you will reconsider or you'll give it another try. So what I have here for today, I have it's a dummy project. It doesn't do anything meaningful except it has some structure. So we have 6 sub-projects, like it's app A, B, and C, and lib 1 and 2 and 3, and they look they are looking as follows. So we have the library, it has some package, there's some class, some method in it with some signature, and that's pretty much it. So the other libraries, if we look at their implementation, they're just dummy, but it doesn't matter for the subject of this presentation. And we have the app modules. They are like the leaf nodes, where they depend on the libraries that we created here. Not this one. So, and the app C is the same, and they have some configuration over here. Like, we specify the main class, we disable some tasks, we reconfigure some tasks, we specify the repos, so on and so forth. And if I build one of these projects, let's say app A, not the Copilot, I run the assemble task here. What's gonna happen? We're gonna end up with a zip file, and this zip file will contain like our jar files and the run scripts. So that's essentially it. And if we look at all these project build files again, we can clearly see that there is some code duplication going on. Like app B, app C, they only differ like here in the essentially package and module name configurations. With regards to the libs, it's pretty much the same. We also have the code duplication going on here in the different files. And honestly, on this scale, like we have only 6 modules, it's fine. I mean, the code duplication is not necessarily evil. However, if we had, say, a multimodal project which had 150 or 300 modules, and that's not uncommon, that's going to be a real pain. Like if we wanted to update, say, the Java bytecode version, which we compile our classes to, we'll have to go over all these classes, or we will try to resort to some sort of workarounds on how we can extract this common business logic into one place. And the next thing which I want to show you there is how we can do this, how we can solve this. There are many, unfortunately, with Gradle, there are many different ways on how you can solve it, but usually only one or two are the ways which are recommended and should be used. So I will show you the way which is the recommended way, and before I show you how it's being implemented, I'll show you what we have in the end. So in the end, now we have pretty clean build configuration. This is app A here, where we only specify the different portion, the main class, main module, and its dependencies. And if I open app B, it's the same. We are now having the information which is only specific to this particular project, not the common. And the common thing is hidden here in this plugin. And this kind of plugin called a convention plugin or precompiled script plugin, which main purpose is to encapsulate essentially your conventions. If you have a Java application which you distribute, then you have a conventions for it. If you have a Java library which you distribute, you have the conventions for configuring the Java library projects in Gradle. So how do we then implement them? Well, there is this special folder called build src, and it's essentially the thing which Gradle builds before it tries to build your project. And there you can place your code of your plugins. It doesn't matter whether it's a convention plugin or a so-called a binary plugin which can be written in Java. You don't need to have it in a separate project. You don't need to have it published to some artifact repository. You can just have it in line within your source code, and Gradle will pick it up and build it for you. So here I have a set of conventions plugins defined, and these are just essentially the Groovy Gradle scripts which we saw are common pieces. For these leaf nodes, the app A, B, and C, we have the configuration we are living on the bleeding edge. We enabled the preview features. It's the Java 23. We disabled the start task because the zip file is enough for us. We don't need a tarball. And this plugin is being compiled by another plugin into something like this. If I look at the generated files here, so Gradle transforms this piece of Groovy into a piece of Java, and then what you can do in your projects, you can just apply it like it was a normal plugin here. And IntelliJ nicely allows you to navigate to it and change this. Well, now there's some probably bug in IntelliJ. It doesn't pick up the syntax, but usually it should pick up the syntax, and you'll have auto completions and all of that. So now if we look at our projects again, like I mentioned earlier, there is no code duplication going on, and if you decided, say, to update your thing to use Java 24, the preview release or something, yeah, all you have to do is go to the Java application conventions and change this one line. And the other thing which you can do with these plugins, you can combine them. So here you can see that this file which I have opened, it's a convention plugin in the build source folder. And here it references the Java conventions, which is another file here. And these are common for all, both libraries and applications in our project. So library convention also uses it, and then just applies the standard Gradle's Java library plugin here. So as you can see here, the baseline, we have Java 21 in the other convention plugin, we can override it with the Java 23 and enable it. Okay, so this was sort of a very simple scenario, not that messy. Like I wish all the Gradle projects were like that, where you can just extract the common pieces into the convention plugin and call it a day. However, usually what you will like when you start working on an already existing project, and if it's built with Gradle, you may end up seeing a bunch of Groovy code just inlined in one of the build scripts. And so here I have kind of a similar thing. So although like this task which I create here, it tries to adhere to all the best practices and the proper APIs which Gradle offers to accomplish what it needs to accomplish, but still, it's messy. Like this is a piece of Groovy code, another piece of Groovy code. Like we don't know the receiver of this, like where this delete method is coming from, and if you have 10 or 15 or 20 occurrences of that, well, your life is not really happy. So how can we fix it? But before we jump into the fixed portion of the talk, let's discuss what this thing is doing. So previously, like I shown you, we were distributing our apps as zip files, like the archives with the start scripts and the libraries. But now, like a new requirement that we have is we want to distribute our apps to be like a standalone, self-sufficient things. And for that, we should be using, let's say, JLink. So JLink, for those who don't know, it allows you to build like a stripped version of the GDK, which only has the modules which your app needs, and it allows you to like bake in your code into that and have something which you can just run, and it will run. It will be very small if you don't use like every single class available in the GDK or other module. And yeah, this is our requirement. So Gradle unfortunately doesn't support this out of the box yet. And yeah, we just solved it by like creating this new task inline in the build script of app A. Does it work? Well, yeah, it does. I can show you that. So here we have the build is successful, our task was executed, and if I run it again, Gradle notices that nothing really changed. Its inputs didn't change, so it didn't run it again. Okay, that's great. So, and I can even run it for you to hear. So I have this nice, by the way, this is like the output that we have. We have the build folder, images, A, which is the name of our app, and we have all these standard like GDK folders or GRE folders with some binaries and the run scripts. The binaries I think are here. Yeah, I'm using Linux, so there's a bunch of SO files. And if I run it now, I can see, yeah, it runs. So it says powered by GDK23, app A did its job and it's finished successfully. Okay, great. But what if I wanted to, say, add the same functionality to app B? It's also like a leaf node in an application. It has a main class. Well, I can simply copy and paste this thing, right? It's only like how many 30 line-ish of code, but we will end up with even more mess here. What we can do? We just learned about the convention plugins, right? So technically, probably we can place it in a convention plugin. However, there are still pieces which we need to configure and pieces which are specific to a particular project, like let's say the main class name, right? So it should be apps B application, and the module should also be apps B, so on and so forth. So this doesn't really scale. We need like a better way. So the better way here would be to start writing things in Java, because this is a Java user group. I'm supposed to show you some Java, not Groovy. So what we can do, well, we can move the imperative part of our task into, well, a Java class. And unfortunately, the code navigation doesn't work here for some reason. But how we can refactor that piece of Groovy code, we can refactor it into a Java class. It's going to be an abstract class which extends this thing called default task, which comes from our Gradle API package. And we don't need to place it in a separate repo or something like that. We can just use our build src folder here. So I placed it in the source main Java folder now, and this task, the difference is that it is now it now clearly defines its inputs here. Like we need the module path for JLink, we need like the modules, list of modules which we want to include into our JLink image. We need the launcher configuration, launcher VM options, and it defines the output directory here. And it also defines some like services, which in this case file system operations, so that we can, for example, remove the folder if it exists before trying to run JLink again, because JLink it cannot work if the output folder already contains something. So we need to remove it first. So here we clearly see the distinction that the like the declarative part is here. These are our inputs, and the imperative part is here. This is our action, and the action is just doing whatever we were doing in that piece of Groovy code. We are invoking JLink here, which we previously obtained using the tool provider SPI, and do some like launcher argument rewrite stuff. It's not really important, but yeah. So this time, if we look at app B, well, we can define a task here. We're going to reference this class name and just set these this configuration. We set the module path, the output directory where we want our image to live in, the launcher config, and so on. Is it better? Yeah, definitely better. So now we can reuse the implementation, but is it like good? No, not really, because here, what is this? Like, why do I have to bother about referencing the jar task and the runtime class path configuration and do it for all my project? Why should I include the group description in it? So not really that useful. Can we do better? For sure. So here, this is all the configuration that I have in my Leaf modules now, at B and A and C. There's no more like task declaration. And if I run the image task again here, we can see that, yeah, this task was run. And if I look at, that was app C. If I look at the build folder, the image was created here. So how can we do this? Like, what do we need to do in order to implement it? Well, we need to actually start writing a plugin in Gradle. So the same magic build source folder, but now instead of a piece of Groovy, we have a bunch of Java lambdas. But they're not scary, don't worry. So this is like the entry point essentially of our plugin. Like whenever we declare something like this, C80 juke JLink application, this piece of code will be executed, and it's defined in the build Gradle file of the build sorts folder. So here we have like the plugin definition. I say its ID is this, which we saw here, and the implementation class is this. And yeah, we are given the Gradle project model, which we can do some mutations to on. And let's start with that. But before we do this, let's look again at the end result. So here, I didn't specify anything new. It was all like it was previously, just the application, main class, main module, with a list of dependencies, and our convention plugin here. So what is happening here? I, again, register a new task. The same, essentially, API is just, it's Java now. Like I give it a name. The output directory I inferred from the project name, so I don't need to specify it manually. I set the group, set the description, set the module path, and yeah, this is our task. But this task lacks the two important parts: the main module name and main class name. So that we're gonna infer from here. This thing is called an extension. And this extension belongs to the application, the standard plugin which Gradle offers, the one which builds the zip files and tar files. So we're going to piggyback on it and do the following. So here I use this API called plugins with type, and I give it the application plugin. And if our project happened to have the application plugin applied, this callback will be like invoked. And here we can access this extension, but now from the reader's point of view, and use the properties for it and assign these properties to our task. For example, here to this property or to this. And this way, we're sort of still keeping our configuration clean and trying to reuse whatever is available. Because usually, well, if the main class for your zip distribution is this, then chances are it's the same for your JLink image as well. But of course, you can override it if you want to. You can do something like tasks with type JLink, what do we call them? Image task, and configure it additionally. Something like this. Yeah, and you can set module path and whatever you want. So this is one way. But let's say these information that we already have in our project is not enough. Say I want to strip the debug information from my images, and JLink, if we look at its options, like there's many. Like you can remove the man pages from the distribution, the header files. You can specify like the NDNS, compression level, bind service, so on and so forth. So for our example, we have a new requirement that app B should we should be able to specify this strip debug option, so that we make probably our life harder if there is a stack trace and we need to analyze what's going on in it. Yeah, let's say we need it. So now if we look at app A, it's still the same. The requirements didn't change. App B, it's kind of the same, but we have a new extension here called JLink application. And now we can specify either we want this 3D debug option to be enabled or not. So if we look at it, at the extension class, it's again an abstract class which Gradle will implement for us and inject into this build script here. And we have a bunch of properties, like the main module, main class, VM options, strip debug finally. And if we look at the plugin configuration here, again, we're doing things a little bit different. So first we create this extension, we register it, saying that when our JLink application plugin is applied, then we'll be able to use this extension in our build scripts. And then we, again, piggyback on the application plugin, but now instead of setting this information, like which we extracted from it, such as main class and main module properties, into the task directly, we're going to set it as the default values into our extension objects, which we created here. And then the idea is the same. We just use the extension to configure the main module, VM options, and finally this new strip debug attribute, which I added here. And it's on the task as well. And I just pass it to the JLink tool. Okay, so...
Sorry, I have a question about where you were showing where you were setting conventions on the extension. I'm just need a little bit more help. So that ext is your own type that you made, right?
Yes, that's here. So I call project get extension create and pass our ext type, which is this.
Okay. Yeah. And so then you're calling get main class. So what's the return type of those ext methods where you can call a convention on it?
Ext.
So methods like get main class.
Yeah. The return type. Oops, not this one. Is property. So this is the Gradle like special API, which you should be using in plugins. It allows you to lazily bind two properties together, because what's happening here, we're just defining our model, and it's not necessarily that we'll need this piece of information. So Gradle tries to do as little work as possible up until the moment when we need it. And yeah, it has this nice APIs like convention. Convention is essentially the default value. And if we happen to override it to use the set method, the set method will take precedence, so it will...
that would prevent someone from setting the value in their build?
No. That will allow them, the opposite. So if we were using set here, that means that if I happen to change it at some point somewhere to something else, I will not be able to, because this set will override whatever I did. But with the convention, it's like the default, the initial value, and the setter is the setter.
Okay.
Okay, any other questions? By the way, yeah, feel free to interrupt. Okay, so here's our new updated plugin where we can specify the custom options. And if we don't want to use it in conjunction with the application plugin, we can just do this. We can apply the Java conventions, which is just the Java, apply our JLink application plugin, and configure everything through this extension here. And it will also work.
So there you're overriding the conventions.
Yeah, technically here, because I don't use the Java application plugin, this callback will never be executed.
Oh, I see.
And here I'm just setting. But in this scenario, let's go back to app A, where I do have something here. I could use JLink application main class, and it will take, so this will take precedence. Like if I want to use a different main class in this particular app.
Okay. So you're fully relying on conventions in app A, and then you're fully relying on explicit configuration.
Yep. And I can mix them together as I want. All right. So this is great. Let's look at another use case: chaining the tasks. So previously I was showing you some bash script which I ran in order to prove you that this image indeed works. But would it be great if we had the ability to do this from here, from Gradle? Like, let's say we had like a another, say, run image task, and that task would depend on our image task. Yeah, we can do that. So let's look how we can do this. So first, let's look at the end result. So now if I refresh the project, we can see that task A has the new image run task in it. And if I run it, what's going to happen? Oops. First, we're going to see that our image is built here. Second, we're going to see that, yeah, our image is indeed working. So if I run the image run task again, and here, our image is not going to be built because it's up to date, although it will be checked for its updateness state. And if I change something in app A, say I'm going to change the main module, well, I will have the error because this module doesn't exist, yet this image task will be invoked. Although, as you can clearly see here, I was invoking the image run. And now I want to show you how this chaining is done the proper way. Because there are many ways, and usually it's a big pain to do this, but with the new Gradle APIs, with the help of these properties and providers, it's actually very simple. So the implementation. The implementation here, we have another task called run image task, and this task now accepts the image directory, and it's indeed the input directory. In our image task, it was an output directory. So when we have like our common main module, main class, VM options things. And what we're doing here, we're just running this Java launcher file with our options here. As simple as that. The interesting part here is how we chain them. So if we go back to the plugin class, here I still have everything which we did. And we have our image task created. It's not the task, it's the image task provider. Like Gradle will only create it when it's needing it. It will not be creating it proactively so that it doesn't do the work which doesn't have to be done. And we are registering another image run task here. And what I'm doing here, I'm setting all these known properties like main class, main module, VM options from the extension. Yet the image directory, that input property, input directory, is set to be the value of the output directory of our image task instance here. So what's going to happen? Like that's all you need to chain the two tasks together. If you know that the output of one task is the input of one task is the output of the other task, you should chain them like this. And because we're using these special like directory property or just property APIs, Gradle will know that this value is produced by the image task, which generates the J-Link image. And that's it. That's all you do, and you get this task chaining for free. However, you may see, and it's pretty common, that people would define this depends on, like one task depends on the other explicitly with the use of the depends on API. This is kind of wrong. Like the only proper place to use the depends on API is for so-called lifecycle task, like the build or assemble, where you don't really care about one task inputs depending on one task, the other task outputs. All you care is that when you run this sort of aggregator task, you want the three other to be run. That's it. So this is the proper usage of the depends on API, and this is the proper chaining for when you care about inputs and depending on them. Okay, so now, by the way, the time check. How much time do we have? 15.
25 minutes.
Yep. Okay. So now let's, because this section is kind of big, I'll try to cover everything which I wanted. Let's pause for a moment for code and think about the distribution of our app. Like now I have this image built and it works great, like I can run it. Can I distribute it? Can I give it to my end customers? Or is there any like problems with this maybe?
Architecture?
Like the thing is, I never specified first the GDK which I want to use, right? I just happened to use the GDK 23 by like IBM, the Semaru one. It works great, by the way. But I didn't specify the version, and if Teresa unfortunately is not here, and it could be a problem because usually, like when you build your Docker images, for example, you do specify like which Java version you use, or at least like the major version, right? Sometimes people even pin to the SHA hash of the image, although there's like some drawbacks of doing that. But still, for us, the first problem is that we never specify the GTK. We don't want what we use as the baseline. And if we want to distribute something, well, probably we do care about like checksums. Like we are using like the certified sort of version of the GTK. We're not using some bootleg build which we did on our machine from the sources or something like that. And with this approach, it works very, very good for the local, like for the development purposes. You can run this image build, check it if it works on your machine. But for distribution, preferably, we need to be specific like this, where we have like the exact distribution specified, and on top of that, we also probably good idea to have the checksums also specified for what we're using in order to like keep our supply chain sort of protected and don't end up with the surprises. The other thing is that I'm using Linux, and most of the server-side apps are probably run on Linux, but this is x64 Linux. Maybe now somebody has an ARM machine, or in production they use the cheaper ARM machines from some clouds. Doesn't really work. So we want this image to be built on a different platform. And J-Link, the tool itself, it allows you, like if you give it the target GDK, like the path to the target GDK, it will surely produce you what you ask it for. If you wanted a Windows image, sure, no problem. It will generate it on a Linux machine. On like the builder machine will be Linux, and it will produce the Windows artifact if you give it the GDK. So it would be great to completely automate this process, and we can do it. So this is the end result. Let me show you what I have in the task graph. If I refresh, I have 3 more tasks which are called image something, and this something we define over here. And if we run, let's say, the Windows task, we will eventually have, that was app A, right? In our build folder here, we're gonna have the Windows x64 like distribution. And if we look at the bin folder here, we're gonna see a bunch of DLL files which will, well, tell you this is a Windows distribution. I have Wine, but I'm not sure if I'll be able to run it using Wine here. But trust me, this is legit. I don't want to fool you here. It's legit. If you had a Windows machine, you could run it over there. So how do we do it? Well, first and foremost, in order for us to use it, we need to fetch this archive from somewhere. And it would be great if we could just reference it as a dependency, like this, right? I say, oops, this is incorrect. Actually, yeah, it should be like this, where I have the configuration called GTK archive Windows x64, and I give it some coordinates. But unfortunately, the vendors, they don't publish their artifacts in Maven Central or any other repo which we can use it like that. However, Gradle is a very versatile tool, and what you can do here, you can define an Ivy repo, and here I'm probably using the official IBM runtimes GitHub repo, and I just tell Gradle that, okay, if you happen to resolve any dependencies from this only group, which this is a synthetic group which I came up with called com-iba-semerus.cdn, just use this pattern. Use the artifact name and the extension, and append it to this base URL. And if I did that, and I'm actually,
yeah. Which I guess is part of the standard Gradle plugin.
This? Yeah. Yes, this is the part of the standard functionality. You don't need any third-party plugins.
Oh, it's just core Gradle.
Yeah, core Gradle.
Okay,
yeah.
Thanks. That's nice. That's nicer than just checking all of the repositories you've configured.
Yeah, like this dependency resolution management, it's actually one more thing which I wanted to show you, because previously we had Maven Central in a convention plugin. Yeah. Now we can just do it once in the settings Gradle file. So we have this Ivy repo defined, we have the include group, and if I comment this line out, because I don't need it, and show you the dependencies task. So Gradle has this very helpful task, core functionality again, called dependencies. I will run it on the app A project, and it will display my dependency tree over here. So these are our normal dependencies that we can see here. And if we find, if we look at here, we can see that besides this runtime class pass, we now have three different, this thing is called configurations in Gradle. Very, very, very confusing name, but this implementation or mains or so, it's called configuration. So we have three new configurations which are sort of referring this IBM Semeru artifact. Meaning that if we refer in this artifact, that we can, Gradle can download them for us. And the good thing about it, we could have written another task which would download those artifacts for us, but then we're getting into the file downloading business where we have to check the checksums. We have to follow the redirects. We have to deal with the connection errors, all that. We have to deal with caching, because Gradle, when it downloaded the artifact once, it just caches it, and if we use it across different projects in our different sub-projects or completely different projects, Gradle will just reuse them. So we get this all for free. We don't need to write this. And like I mentioned, the checksums, here I'm using the functionality called dependency metadata verification, which is essentially an XML file which you can create with some task in Gradle, and it will keep essentially a log file, the jar file name, pom name, it's SHA-SUM, SHA-256 checksum. This is great because it protects you from the supply chain attacks. These tarballs or zip files, they're also part of this. So we get this for free. Yep.
This file, is this something you would check in somewhere?
Yeah, yes, you have it checked in your repo.
Okay.
And if you want to generate this file, you call, I believe it's I'll use IntelliJ, will show me the hint here. yeah, write verification metadata, and here I'm just using the help task because the help task will just trigger all the tasks to be initialized, and you will probably fetch all the artifacts and end up with the metadata. Very useful feature, and they also recently made it like a GA. It's not more incubated, probably Gradle 7, I think. So, okay. So now we have these artifacts. They will be downloaded for us. However, let me show you how they're going to be downloaded. So let's go back to our plugin here. So before I jump into the artifacts, I want to show you one more API which Gradle offers, and this API is called named domain object container. So in our build script, I have essentially an arbitrary number of distributions. I can do something like this, or Windows ARM64, let's say. There is a distribution, or I can do something like this. So we can either specify 0 or more of these, and it's like extensions, but yeah, you can have a list of extension options. So I have another sort of extension object here, which is called image, where in the constructor we specify the name, and we have these two GDK archive and group properties. And if we look at our build file over here, these are our properties. And this is the name which we passed in the constructor. And then we have this callback called, so we registered as an extension and subscribe to the callback called all, where we register a new task. But this time we are again applying like our common settings here, like the launcher, VM options, strip debug, the output folder, all of that. But we are setting this get cross target GDK path, which is the directory property, from where the J-link should be. Oops, not this one here. Should be using basically the target JRE, which it builds to. So regarding the dependencies, like how do we make Gradle to download them? Well, first we need to add a dependency to a configuration, and we can do it explicitly this way, like I showed you here. But this is an implementation detail. We need to do it programmatically. So we do it programmatically here. I have a new configuration created called GDK archive plus like the name, whatever we defined here. And I'm adding a single dependencies to it. And the dependency classifier is like this. The group, this artificial group which we came up with, the GDK archive, out of it we extract the name and the extension. So essentially this line is equal to this line here. And when we resolve this configuration, and by resolving I mean I'm doing this, pretty cryptic, but trust me, when you wrap it in the files, and it's like the normal way, you're gonna end up with the single file which will point to the file which we downloaded, and this file will be stored in Gradle caches. But it's not enough, right? Because we don't need the zip or tarball. We need the extracted, exploded version. And for that, Gradle offers us another extension point, and this extension point called artifact transform. So we can transform the artifact from one shape to the other. Say, in our case, it's going to be from the archived version into the exploded folder version. And what we're doing here in our configuration, because here we created a new configuration, we added a dependency to it over here, and we specified that this configuration has the attribute called extracted archive. And by default, this attribute, well, it doesn't exist, it's set to false. So our artifact transform, when we register it, we tell that this artifact transform will convert artifacts with attributes zip, artifact type zip, and extracted archive false to artifacts with attributes zip, extracted archive true. So we will run this artifact transform here. We're going to extract whatever we have, either a zip file or a tarball, and we will write it to the destination path, which Gradle sort of gives us the base destination path, and we just create a folder in it, and this folder will be our extracted artifact.
So you mentioned caching. Is all of the sort of configuration around this?
Yeah.
Is that to support that this is done in a lazy and cache?
Yeah. But I have this annotation here, right? Disable caching by default.
Okay.
This is for the remote cache, because Gradle offers you local caches. They are always enabled, but you can also push your data to some remote location and reuse it across many like Gradle instances. So it's not worth caching like the extracted version of the artifact. So it's again a little bit So at the end of the day, like we will end up with the exploded version of the archive. And if I run the image task again here, image Windows x64, I have the info logs enabled. Oh, it's up to date, so I need to remove the build folder because I actually need it to run and produce some logs. So I will kill this folder. Okay. Run the task again, and we will see that resolved cross target GDK23 Windows x64, and it's located here in this file. So I'm going to open the Explorer, and well, it's already opened. So if we look at the path, it's Gradle caches, whatever version, transformed this, transformed IBM Semeru, yada yada zip, and finally rsync. And we have the exploded version, which we can later on use in our task. So the task itself, it has no idea where this GDK distribution is coming from. Technically, we can just hard code the path to it and use it. But the other abstraction, the artifact transform and the Gradle artifact resolution kicks in. It either downloads this thing from the internet or uses the cached version, extracts it, and gives it to this task absolutely transparently for us. Sorry. Okay, so do we still have time, or is it set?
About 10 minutes.
10 minutes, okay. So we have two more topics which I wanted to cover, and they are simpler than this. So the first topic is testing. Okay, this is all great. We have the plugin which works, but preferably you need to test your thing, and especially if it's not like a one-off something and you would like to distribute it, reuse across different projects or even within one project. So how can we test stuff there? Well, there are essentially many options, because these plugins are a normal Gradle project. Like you can create the test folder, add the JUnit or whatever you use, testng, to this project in the build source, and do unit testing or do whatever you want. But I'll show you here the plugin which is published on the Gradle portal. It's the father of this talk kind of thing. The JLink plugin which you can use and add to your project, which is being maintained by myself. And it has an extensive test suite along with it, and at the end of the presentation I'll share the links to it. But we're going to look at one of the functional test cases, because unit testing, I hope everyone here know how to test the inputs and outputs of like your methods. But the integration testing, or rather functional testing here, is not that difficult, and it's not that different either. So what I have here is a bunch of like test cases, and for this particular plugin. And yeah, here we have a test case which is framed like this. So I have a test fixture called Gradle build. It's a class with some properties, and I initialize it with the following content. So I give it a build file. It's inline to essentially a string. I give it the settings file. I give it like the main class, main module. So my test fixture, it writes this into a temp folder, result against like the current folder, and then it gives me back this thing called Gradle runner. It's a standard like testing piece of standard testing infrastructure which Gradle offers, and what it does, it essentially plugs in your class path and execute the command which you give it. So here I execute the image run command, and I expect that the output will contain the task image run built successfully, and that the standard output will equal to hello and world, which are like coming from that. So there's a bunch of these test cases. I probably tested the J-Link tool itself rather than my plugin here, but they're very helpful. Like I try to add in JDK 23 here to make sure my plugin works with it. Yeah, and I'm pretty sure it works because all these test cases, they cover the various functionality. Okay, and yeah, the last thing which I wanted to show you is how you can develop Gradle plugins which, let's say, you forked. Say you really like my plugin, it mostly works for your needs, but you want to add something to it. Like, I don't know, maybe add another, let's say, J-Link, sorry. Add another J-Link option which this plugin doesn't support. Like, what could you do? You can, well, fork this repo or clone it on your local machine, do your changes, publish it to your Maven local repo, add this repo to the settings file here in the, oops, sorry, my laptop. It's called plugins management, I think. Repo like Maven local, and test it. Then probably publish it somewhere else, refer it. But this is very cumbersome. The better way here, you can use the feature called include builds. So here what I'm doing, I'm just copying the path to this plugin on the file system. It's a separate project. And I'm gonna actually close this window. And instead of this, I will do include build and just pass the path to that repo. And when I refresh well, I need to remove the one thing here, the metadata verification, because this file doesn't contain all the other dependencies that plugin uses, so I'll temporarily disable it. And if I refresh the task tree, we're gonna see that here we have two projects, our current sandbox, playground, and that included build. And it's in IntelliJ also is over here. And you can change it to your liking right here, do whatever you need, and it will be automatically available for you to use within your, oops, not this file. Let's say you can use it in your convention plugins, or you can use it in here. You don't need to specify the Maven local repo. You don't need to worry about publishing the updated version, so on and so forth. Okay, so yeah, that's it for the presentation. These are the links where you can find the Playground project and the J-Link plugin I mentioned. And yeah, thank you very much for coming.